Welcome again to this session. We are going to be starting from where we stopped in the last session. So last session, we looked at descriptive statistics, and we also looked at the measure of central tendency. So today, we are going to be looking at measure of dispersion, and we are going to be looking at the 5-number summary if the time permits us. So let's look at measures of dispersion. So we are going to be looking at what they are. We'll be looking at how we can compare them and when to use them. So what are measures of dispersion? In statistics, measure of dispersion is how we measure how far values spread out from the center value and how they spread out from one another. So, for example, this particular value here is, let's assume it is the center value. And let's look at how some other values are arranged around it. If you look at this center value and all of these other values around it, let us compare it with another center value. This is also a center value, and let's see how other values are spread or arranged around this other center. So you can see the difference between this center and this center. The values around this center are very close to the center, and they are also close to one another. Now, let's look at this one. You can see that the values around this center are a little bit far apart from the center, and they are also far apart from one another. So the concept is that we can have the same center, but if the other values are spread in different ways around the center and from one another, it brings around another context. So the measure of central tendency try to say what is the single value that we can use to represent our data or to represent a population, a sample, and so on. But a single value is not enough. A single value does not provide the context. And we are going to be looking at a particular case scenario at the end of this particular session, where we are going to be seeing how two centers can be the same, but the spread around them create a new context entirely. Now, when we want to talk about the measures of dispersion, let's talk about the range, which is the difference between the maximum and the minimum value. So range is just to let us know, okay, if our maximum value is this and our minimum value is this, what is the distance between them? So if you go to a particular school and you say, okay, this particular guy who have just finished their exam, what is the range of their scores? So you are saying that what is the difference between the maximum score and the minimum score? So if they say that, oh, the range between the maximum score and the minimum score is 50, it means that or let's say, and then you ask for another class and they say, oh, the range between the maximum and the minimum score is 30. So it tells you that the people in the second class, their performance is close. It's closer when compared to those in the first class, where you have a range of 40, which means that the difference between the maximum score and the minimum score in the first class is 40. So a range is used to see how far the maximum value is far apart from the minimum value. Range is very simple and is very quick to understand. So it just gives us a very quick understanding of the spread. But the problem is that range is very sensitive to outliers. For example, look at a class where the highest score is 95. The second to the highest is 60. You understand now? And then the lowest score is 30. If we want to calculate the range will be between 90 and 30. But if you look at it, the 90 in that class is an outlier because the second person in that class scores 60 and other people follow in that direction. So range is very sensitive to outliers, and that is why it's a very vulnerable way of trying to see how spread our data is. Let us look at standard deviation, which is a common term that I believe every one of us here would have encountered in the past. Standard deviation is the measure of the average distance of the data points from the mean. So what the standard deviation is doing is that it looks at the mean and it puts the mean at the center, and it looks at how every other data points are far from the mean in terms of their average. It is convenient to interpret. Why? Because standard deviation is in the same unit as the data, and it is the most commonly used because of its interpretability. And in the next slide, we are going to be looking at a scenario, and you will see how standard deviation matters. Now we look at variance. Variance is just like the scale of standard deviation. Standard deviation and variance are measuring the same thing. The only difference is that the variance is measuring that distance in form of scale, while the standard deviation is measuring it in the same unit as the data points. So variance is not in the same unit as the data. So in some advanced calculations, people use variance because of some reasons. However, I will not be speaking about that in this particular discussion. Now, look at this particular data points. If I want to calculate the range, the maximum value is 5, isn't it? And the minimum value is 2. So if I remove 2 from 5, we have 3. So you can see that the distance between, if you look at the spread here, if we say that the spread is 3, it looks a little bit reasonable because you can see that they are not so far apart from one another. However, if I add another data point, 33, at this point, our range becomes 33 minus 2, which is 31. And you cannot use that to really explain or to represent the difference between, like the spread between these data. So that is why range is very sensitive to outliers. Now, look at this particular diagram here. We have the center. You can see that this is the center. We have the first distribution. The first distribution is this guy here, the thick line. And the second distribution is this guy with the hyphenated line. So you can see that the hyphenated line spread out more than the thick line. So it means that the data set inside the hyphenated line are far apart from the center. You can see they are far. Look at this space. There are still some data sets inside the hyphenated one here, data set here, but when you look at the thick line, there are only few here, and there are only few at these points. So this is a distribution of two different data sets with the same center. This red line represents the center, that is 5. However, because of the difference in their standard deviation, you can see that the spread of the data set is different in the two distributions. Now, what is the implication of this? Let us see that. Now, we have been able to look at the measures of dispersion, we have compared them, and then we have seen when to use them that we cannot use a range when there are outliers, because range is sensitive to outliers. Now, like I was saying before, let's look at different scenarios. Let's say 2 scenarios in order to explain how 2 data sets or 2 populations, or let's say 2 samples, can have the same mean or the same center, but their difference in the standard deviation can make a whole lot of difference. Now, assuming you are a data expert or a decision maker in an organization, and your boss knows that you are a professional data analyst, and the man says that, can we look at the buying behavior of our customers in the last 1 year from 2 different departments? So we have department A, and we discover that the average sale of, let's say we look at 1,000 customers, we sample 1,000 customers out of every customers under department A, and we discover that the average sale of, or let's say the average amount that our customers were spending was 50,000 naira. But when we calculate the spread, that is the standard deviation in this population was 2,000 naira. And then we look at department B. Department B also have the same average sale amount, which is also 50,000 naira. But when we look at the standard deviation, trying to see the context in terms of how their buying capacity is different from this, is far from the center and far from one another, we got a standard deviation of 20,000 naira. So the 2 departments have the same average sale, but different standard deviation. And there comes a question. Do you want to introduce products that cost 70,000 naira or more to this group? And the same question goes to this particular department. So your boss asks you that, hey, Alpha, we want to create a new product, and that product costs 70,000 naira or more. Can we introduce it to the 2 departments? So you have done your sampling. The average sale is the same in both departments, but the standard deviation in department A is 2,000 naira, while it is 20,000 naira in department B. So in order to have an idea of what is happening here, I use Python to generate a density plot that will give us an idea of the probability of having a particular save a month in the two departments. So let us look at it. Good. Now, this is, you can see, mean of 50,000, standard deviation of 5,000 naira. This is, so let's use standard deviation of 5,000 naira here and standard deviation of 20,000 naira. So the blue represents department A with 50,000 naira as the mean and 5,000 as the standard deviation. You can see that everything is inside this tiny box, and you can see how tall it is. What does it mean? Let me explain this and look at it carefully. This is the mean, 50,000, isn't it? It is at the center. But if you look at it, you can see that at this point, everything has thinned out. What this is telling us is that this is about 30,000, that the probability of having a customer who will pay 30,000 is very low in this population. And the probability, look, at this point, we are at, I think, 70,000. So the probability of having a customer who will pay 70,000 is also very low at this point. However, the probability of having customers who will pay between, let's say, 30,000 to like 65,000 or 60 something or 70,000 is very high. So almost everybody in this population is only willing to pay or to spend on our products between price of 30,000 to price of 70,000. So what does that mean? It means that any product based on our data that we want to push into this population, that is the population in the department A, that product should be between 30,000 to 70,000. And product around 50,000 is going to be very accepted in this population. So which means that we selling a product of 70,000, pushing a product of 70,000 into this population is not the best, because look at where 70K is. 70K is around here. So only few people are willing to pay it. You can see it's around there. Only small space. Compared to top like 60,000, 65,000, 50K, 45K, 30K, and co. Now, let us look at the red plots, which represent the population with standard deviation of 20,000. You can see that this is spread out. You can see it's spread out, which means that if you look here, this is 100,000. Even in this place, we even have some chance of having customers who are willing to pay 100,000. We have customers willing to pay above 75,000. You can see from here to here are customers who are willing to pay above 75,000. And even from here to, we have customers who are willing to pay below 25,000. In fact, we have customers who are willing to buy our some of our products for like 10,000, 5,000, and co. So which means that we can put a product, different products with different prices from 5,000 to 100,000 comfortably into the second population, because there are different type of buyers who are willing to pay at different price. So we can send different type of products at different price. But when you compare to the fourth department, you should only try and push products whose price is in the range of 30,000 to 70,000. And majority of those products should be within like 40,000 to 60,000. That is the lesson about how the average, that is a center of our data set, does not explain everything until we try to see how spread other values are from that particular center. I think this is a simple example, and I'm saying this because when you are working for an organization and probably they ask you, what is the average sale? What is the average attendance? And so on and so forth. When you generate your average using software like Excel, Google Sheets, Python, Power BI, and Co., as a data professional, you should know that you should look at the spread, like standard deviation, so that it can give you an idea of how things are spread around the center. Very good. Now, let's look at other examples of measures of dispersion. At this point, we are going to be looking at percentile, quartiles, and the interquartile range. So these three concepts are used to measure how we can divide our data into segments and identify the position of individual data points in that data set. Now, some people also call these terms the measure of position, but majority of the textbook still categorize them as measure of dispersion. So, for example, you look at all the sales that the company has made in the last 1 year, and there are several values, 100,000, 500,000, and co. And you want to look at it that, okay, at what position does 20,000 naira stand based on how much our customers are paying? This concept is going to give us a whole lot of in-depth understanding and context. So let us look at them one after the other. Let's look at percentile. We are going to look at quartile and then the interquartile range. Now, you know that when we talk about percentage, we are talking about 100%, isn't it? So a percentile is a way in which we divide our data set into 100 different positions. And the percentile is the value below which a percentage of the data falls. This is a big grammar. Just listen, don't get confused. Now, like I said before, it divides the data into 100. So let me give you an example. Let's look at two students from two different schools. So we have student A going to school A, we have student B going to school B. And then we ask student A and say, guy, how far? What did you score in your chemistry? And the guy said, oh, I scored 90% in my chemistry, or my score was 90 over 100. And you say, oh boy, you know Buko. But the next question is, okay, or before we ask the question, let's ask student B. I said, student B, how far? What did you score in your chemistry? And student B said, oh boy, the exam was tough. Oh, I scored 60. Now, you should know that the two students are from two different schools. They are marked or they are graded by two different teachers, and they did two different questions, even though the exam is still, like you said, was still on the same topic or the same subject, that is chemistry. Now, how can we really know which of them has done better? If, like A layman will say, oh, this guy scored 90. The guy is very good in chemistry. Why this one scored 60 is not as good as A. But a statistician, somebody who have an understanding of data, like you are acquiring the knowledge now, we ask the second question and say, okay, let us compare each student to other students in their school who took the same exam with them. And let's use percentile to do that. And then we ask student A that, okay, you score 90, a very good mark, fantastic mark. That 90 is at what percentile? And the guy said, oh, it is at 68 percentile. What does that mean? It means that 60% of the scores in that class lie below 90. So 60% of the scores lie below 90. So there are another 40% of the scores which were above 90. To say it in a simpler way, it means that student A performed better than 60% of the students in the class, while there are some other 40% of students who did better than student A. Now, if you now ask the second student, student B, that alpha, at what percentile is your score? And the guy says, sir, my score is at 98 percentile. What does that mean? It means that even though the guy scored 60, which you calculate, that score, there are 90%. That score is above 90% of other scores in the class. And it is only 10% of other scores that are above the score, which means that student B with 60% or a score of 60 actually outperformed 90% of the students in his class, while it is only 10% of other students that actually perform better than him. So that is how percentile works. So percentile will make us to understand the position of a particular value when we compare it to other values in the same population. Now, let's look at it like this. Assuming you are working for a company and you want to release a new product, and your boss said, let us do a form of a survey. So let's show whether 1,000 people, 10,000 people or more these products, and let us ask them how much are they willing to pay for that particular product. And then some people say they are going to pay 5,000. Some said they are going to pay 11,000. Some said they are going to pay 20,000. Some said we are only going to pay 1,000. And to have several values based on what the customers were willing to pay. And then we choose a particular value. Let's say we choose 10,000 naira. And when we calculate the percentile, you know, I told us before that we don't need to use your own hand to calculate it. The softwares like Python, Excel, and Co are going to generate these values for us. By the time we start our Microsoft Excel course next week, we are going to be seeing how we can generate all of these using our softwares. Your goal as a professional is to be able to understand what this value represents and how to make decisions based on them. So let's continue. So if 10,000 naira stands at 80 percentile, 10,000 naira is at the 88th percentile. What does that mean? It means that that particular amount of 10,000 naira is above 80% of other values in that data, which means that there are 80% values under that 10,000 naira. That is grammar. Simply put, it means that it is only about 80% of our customers are not ready to pay up to 10,000 naira for that product, because 10,000 naira is at 80th percentile. So it is lying above 80% of the values that our customers choose for that particular product, which means that about 80% of our customers who actually value that product are not willing to pay up to 10,000 naira, whereas 20% at the top are willing to pay up to 10,000 naira and even more. So some of us here are business owners and business gurus. Do you want to make that price of 10,000 naira to be the price of that product? The price that 80% of the people you ask are not willing to pay. Only 20% are willing to pay that price and above. Now, if you now check for another price, 7,500 naira, and 7,500 naira stands at 48 percentile. What does that mean? It means that 7,500 naira is a value that 40% of the price our customer choose lie below. So which means that it is only about 40% of our customers who are not willing to pay up to 7,500. The remaining 60% at the upper level are actually willing to pay 7,500 and above. So you know that, okay, if I put the price of this product at 7,500 naira, about 60% of our customers are willing to pay for it and even to pay more. What if we choose 6,000 naira, and 6,000 naira stands at 28 percentile? It means that out of all the values that our customer choose, it is only 20% of them that lies below 6,000 naira, which shows that about 80% of our customers are willing to pay 6,000 naira and above for our products. And I believe that some of us here who are business gurus, you will want to go for that 6,000 naira price. So you can see the difference. 6,000 naira and 10,000 naira. The difference is just 4,000. But the willingness of our customers, you can see the difference from 80% to 20%. So that is how we use percentile. Some of these concepts look very abstract, but if you can listen to this video over and over again, you are going to get it. And by the time we are doing some of the projects in our Microsoft Excel class and also in BI tools like Power BI and Tableau, in the future, we are going to be doing some projects that will put some of these into consideration. Let's look at quartile. Quartile is a special form of percentile. You know that percentile divide everything to 100, isn't it? Quartile, like the word quarter, quartile just divide everything into 4. So we say there are 3 quartiles. We have Q1, which is quarter 1, quartile 1, which is the value that 25% of other values lie below. We have P2, which is the value at which 50% of every other values lie below. And Q2 is also the median, if you can remember. That median is the middle value. So Q2 is that value that 50% of our values lie below. 50% also lie above it. Then Q3. Q3 is that value that stands at the 75th percentile. So Q1 is 25th percentile, that is 20% of our values lie below it. Q2 is our median, that is 50% of the values lie below it, so which makes it the middle number. Then we have Q3, which is the value that 75% of our value lie below, and we can say that is the 75th percentile. Somebody will ask that, what of Q4? There is no Q4, because if we say Q4, we are saying the value that every other values lie below. So we talk about Q1, Q2, and Q3. Now, why is Q1, Q2, Q3 good? For example, look at our previous example. You know that instead of looking around, you can just say, okay, let's look at Q1. If Q1 is like 7,000 naira, it means that 7,000 naira is the value below which 25% of all the price chosen by our customer lie below. It means that 75% of our customers, or 3/4 of our customers, are willing to pay that price and above. Now, like I said before, Q1 is 25% of data fall below that value. Q2, 50%, which is also the median, and Q3 is 75%. Now, we have what is called the interquartile range. So you can see that interquartile range is a range between the quartiles. But which quartile in particular is the difference between Q3 and Q1? You understand? So, which means we want to see the difference, how far our third quartile is from the first quartile. In a simpler term, it tells us how the middle 50% of our data is spreading. I won't talk so much about this. And interquartile range is so important because it allows us to eliminate outliers. And this may look confusing, but we are going to be applying it in the future, this particular formula. So assuming you have a data set, and that data set has outliers, and we are looking at how can I deal with these outliers. You can use this formula. So you can say, okay, the lower limit is Q1 minus 1.5 times IQR, and the upper limit is this. And any value below the lower limit, you remove them from the data. Any value above the upper limit, you remove them from the data, and everything in between is what you are going to be using for your analysis. So I think we should stop here today. We won't be able to talk about the 5 number summary today. So I will be talking about it first thing on Friday. And we can see how far we go on Friday, which is going to be like the last session of this particular course for this cohort. I believe we have had a nice session, even though some of these things might look confusing. Just try and watch the video over and over again, and as we practice with these concepts in the future, it's going to be really interesting. This is important because you being able to understand these concepts is going to make you to be very professional, and you're going to understand the data of your organization in a more in-depth way than somebody who is just saying what is the mean, what is the average, what is the maximum, what is the minimum. So thank you very much. We are going to be ending this session here until we meet on Friday by God's grace.